Okay, now let's get started. So I'm going to share my screen. Okay, there is one thing we need to make an announcement. If you are graduating senior, so you are going to graduate in May, please send me email and let me know. So you will have final exam earlier. So graduating senior will take a final exam earlier. So let me know if you are going to graduate in May this year. Okay, let me send me an email so I can arrange your time to let you take the final exam earlier. Okay, let's see, we have this chapter 12. So today we're gonna learn chapter 12. Value at risk and expected shortfall. Okay, the question being asked in value at risk is typically asked what loss level is such that we are X% confident it will not be exceeded in N business days. We have graduate students, especially in finance. When you talk about you have a customer and typically ask you the similar question. So they give you $1 million US and ask you to invest. So ask you, you know, they sometimes they have concerns, they care their profit. But the most important thing, the people will ask you the question is, what will be the maximum loss? Because they give you 1 million and ask you what is the maximum loss. So you might have to answer that question. Nobody wanted to lost all those 1 million US dollars. So they wanted to ask you what is the maximum loss. So that's their bottom line. And so you might answer that question. Okay, this is we have something like an X% confidence. So about so nobody can tell anyone that you are not going to lose anything. So investment is risky. Okay, but you can tell them, okay, we try to minimize the risk. So this is what we can do is about we can have 99% confidence your loss will not exceed 10,000 US dollars. So you give me 1 million, and so we have about 99% it won't lose money more than 10,000. That's the correct answer. You might, should talk to your customer. Okay, that's why, in this chapter, we talk about the VaR. Okay, the VaR is, you can see the A is a smaller letter. So if the VaR is, this one is smaller. And so what that means is not the different we have. There another term we have is called, okay, both of them are, all of these three letters are capital letters. This is a auto-regression, okay? And so auto-regression is a method. This another VaR is the auto-regression method. This VaR is different. We have this the value at risk. So in order to differentiate between these two, you can see that this is a is a smaller letter. So we have value at risk, and we also have VaR. Okay, VaR is a regression method, is auto regression. So don't get confused between these two. You know, sometimes we talk about this too. Both of them very popular in finance. Okay, so VaR and regulatory capital is regulator-based capital they require banks to keep on value at risk. So the market risk capital has traditionally been calculated from a 10-day VaR estimate where the confidence level is 99%. So this is very important. You know, some of the capital you have to be 99%. Some of the capital even higher, so 99.9%. So based on the risk tolerance of the customer. Actually, this is one of the things was written in Basel III. So the all the capital management part in the bank must to have a clear statement of your possibility of default and value at risk. So the advantages of a VaR is, okay, it captures an important aspect of risk in a single number. It's easy to understand, and it asks the simple question, how bad can things get? Okay, and for example, in the past several weeks, we have we can see the U.S. stock market, NASDAQ, S&P 500, the stock market index drops. It drops, a huge drops. So in that case, people might lose a lot of money. One day they drop beyond 7%, to touch the circuit breaker. So it's 7%, and then they drop another more than 7%. Okay, the next level circuit breaker is 13%. So in that case, you lost a lot of money. So people typically care about their risk, how bad can things get. Okay, so let's see, we have example, what will be the VaR. Okay, so for example, the gain from a portfolio during 6 months is normally distributed with mean of 2 meaning and a standard deviation of 10 meaning. So on average, the gain from a portfolio is 2 meaning, but it has standard deviation. The standard deviation measure the risk. Okay, the deviation could be 10 meaning. So the question is, what is the 1% point of the distribution of the gain? So in another word, it is the 99% of confidence level. So what will be your maximum loss? Okay, so how we answer that question, so we can calculate the VaR based on this information. Okay, let's see, I give you Excel spreadsheet, so I can pull up this Excel spreadsheet, and you can see this is the question we have. Okay. So we have this question is that the gain from a portfolio during 6 months is normally distributed with a mean of 2 million and a standard deviation of the 10 million. So the first we know that this is going to be the mean, okay, the average gains, average. And the standard deviation is 10 million. Okay, the standard deviation. And you have the 99% confidence interval. So if you have a 99% of a confidence interval, the alpha, which is the x, is going to be 1 minus 99% is 1%. What will be the 1% chance of your losses be greater than what amount? So how you do that? So we can do is that I give you the picture is looks like this. Okay, so it's going to be so we assume that is the gains during 6 months is normal distribution. So remember, so we have a historical gram. Histogram is going to be this curve looks like is going to be the normal curve, right? The normal curve. So the normal curve, you have a two tails on both sides, each side. So the, okay, this is the percent, that's 1% that could lose, because the losses will be in this gray area or the shaded area. Okay, so you can see this is the not shaded area, that's going to be your gain. So you can answer your customer's question is that, okay, 99% of the chance the gains will be within this white area. But, you know, we could lose money within this area, so that's possible, okay, to the 1% level on the left shaded area. Okay, how much money that would be lost? Okay, that's gonna be your calculation. So we typically we can use the VaR, which is the equation in 12.1. So when the loss in the portfolio value has a mean of mu and a standard deviation of delta, so the VaR is going to be the mu plus delta times the norm's inverse. Okay, the n raised to the power of -1 is the norm's inverse of that probability x. So x is the confidence level, okay? And this the n inverse is the inverse cumulative normal distribution. Okay, so this one you can calculate in Excel. You cannot handy, you know, by hand. So you can calculate, but it's I post a video about what it looks like, you know, how you can calculate by hand. But in Excel, you can use the norms inverse function. Okay, so let's say this question we can do is go back to this. Okay, the standard deviation we have is 2, right? So standard deviation is 2. The mu is mu. The standard deviation is 10. Okay, so what will be the VaR? Okay, the VaR you can do using this formula, right? Equal to the mu, okay, plus your standard deviation times, okay, the norm's inverse. Now we have to use the function is called norm inverse Okay, norms inverse function. Okay, norms inverse function, you can see they ask you the probability. The probability is 1%. Okay, so we put on 1%, right? So the VaR you have, that's your 21.26. Okay, that's exactly how you can get to the 1% VaR is 21.26. Okay, 21.26 or 21.3. So they rounded to only one decimal. Okay, any questions? Okay, so I will upload this file onto Blackboard. So okay, so you can use this formula and the Excel function so that you know how to do the VaR using Excel. Okay, and next we talk about the expected shortfall. Okay, so expected shortfall. Expected shortfall, what is the difference between these two? Okay, so the VaR satisfied the first three conditions, but not the first condition. So expected shortfall satisfy all four conditions. So so basically, the risk measure, they have four different properties. Okay, and so this is the properties of coherent risk measure. So you can read this one and if you want to, but it's not required. Okay, so what we need to do is we only need to estimate expected shortfall. Let's say, okay, this is the project that we're gonna do this one later. So I will show you the same question we did in this Excel spreadsheet. Okay, so to calculate expected shortfall, this is the formula you need to use. Okay, the expected shortfall. Okay, when the loss is assumed to be normally distributed with mean, mu, and a standard deviation of delta, expected shortfall with a confidence level of X is given by 12.2. This is the equation. Okay, so you can see this in this equation, you have the expected shortfall is a standard deviation of the moon plus a standard deviation times E, and E is exponential, right? Raised to the power of negative y squared. So what is y? Okay, where y is the x percentile point of the standard normal distribution. Okay, it's the point on normal distribution with mean 0 and a standard deviation 1 that has a probability 1 minus x of being exceeded. Okay, it's okay, so you see this word is kind of confusing that, okay, we have to calculate y before we use this equation. So what is y? Okay, I will show you how to calculate y, and then you can calculate expect shortfall. Okay. Let's say we did that. Okay, so let's say we go back to question. Okay, so we have this question. Suppose that the change in the value of a portfolio over 10-day time zone is normal distribution with a mean of 0 and a standard deviation of 20 meaning. Okay, the mean is 0, standard deviation is 20, right? 20. So what will be the 10-day 99% VaR? Okay, the first we calculate the Y, okay, for 99% VaR. Okay, how you calculate the Y is going to be using norms inverse. Okay, so what is Y? Y is equal to norms inverse. Okay, that's this is a n raised to the power of -1. Okay, that's the same thing. Okay, norms inverse equal to norms inverse function. Once you open parentheses to ask you the probability, 99% of confidence interval. So you put on 99%. Okay, that's Y. Okay, so the Y is, you get this Y, this number you get already, so that you substitute this Y into 12.2. This is the equation. Okay, so okay, let's see what will be the 99 10-day VaR. So 10-day 99% expected shortfall, because you have to do this when you calculate. Okay, this is the moon, right? Plus the standard deviation delta. Okay, this is very easy, you know, to get. You get wrong. Remember, so we have this one. You look at this equation; it's very easy, you know, to get. You get the wrong number. Okay, so this part, okay, is goes to the y squared goes to the exponential. So you need to have a, let's do the numerator. Okay, numerator exponential. Okay, raised to the power exponential sign, and then you do exponential raised to the power negative. Okay, this is your y. Okay, y squared. Okay. And then the whole thing. Okay, so this is exponential, and then you the whole thing divided by 2. Okay, now this is your numerator, right? And then you another parenthesis divided by, and okay, this is denominator. So we'll do the denominator. Denominator is going to be square root. Okay, we have the square root, and 2 times pi. Okay, 2 times 3.14. Okay, that's 2 times pi. Square root of 2 times pi times 1 minus this. Okay, 1 minus the x. Okay, the x you have is 99%. Okay, so you have 99%. And let's give you the denominator. So we have for this one close parentheses. And then you have another close parentheses. So let's give you the whole thing. Okay, make sure that is not correct. So something very easy to get this one wrong. Okay, let's see. We have on this one. Okay, so I got this one. It's going to be is to exponential raised to the power of 2. Okay, so we do this one. Is to the power of 2. Yeah, so So I just maybe click on this one I did before the class. So that's okay. So this is the first part. This is the move, right? And this is your standard deviation times, okay, exponential raised to the power of this negative. You need to square that, okay, and put another parenthesis, and this is divided by 2, and that's this part. Okay, very easy, you know, to get wrong. Okay, this is a raised to the power of y squared divided by 2. And then you divide it by the square root of the pi times 1.x. So you can see this one. If you do this one, so you have a expected shortfall. Okay, so I think here is something we need to do is this one. Okay, is this one. Yeah, so be very careful. You know, this one is very easy to get something wrong. So this this is the correct formula. So I want to upload this one so you can check the correct formula for expected shortfall. And so I did this for you. And so I will upload this file on Blackboard. And so once you have the 10-day expected shortfall or the VaR, and you have, okay, this is for like a 1 day, right? The 1 day, the VaR. Okay, this is how you calculate the T-day VaR, okay, or T-day expected shortfall. So when you have only 1 day, so you have to, like say 1 day VaR, you calculate, you will times the square root of T. For example, you know the VaR for 1 day VaR, but you wanted to know what is the yearly, okay, yearly VaR. Okay, 1 day VaR, that means the maximum loss or the loss could occur during 1 day. So what about the loss could occur during that year? Okay, the T in finance, I wanted to tell you that it's very important and to remember the T for the whole year. So your use is 252 days. Okay, do you know why you use 252 days instead of 365? Okay, we count only trading days. Okay, it's not calendar days. Okay, for the whole year, we're using 252 days. What about if you have a weekly VaR? So, and then you times the square root of 52 weeks. So 1 year you have 52 weeks. Another number is for a month. So 1 month, you will have 21 days, right? 21 days. Okay, 1 week, you have 5 days. That's the trading days. So we count the T is only count the trading days when you calculate the VaR and expected shortfall. Okay, any questions? Okay. So this is the practice question. We have example 12.5 and 12.7. So each of the 2 independent projects has a probability of 98% of a interval at a loss of 1 minute and 2% of the probability loss of the 10 minute, right? So what is 97.5% VaR for each project? And what is 97.5% expect shortfall for each project? And so what is the 97.5% VaR for the portfolio? And what is 97.5% expect shortfall for the portfolio? So that's so you can practice that question. So because I have the assignment for you and similar to this one. So after the class. So that's we talk about for the VaR and expect shortfall for today. And so any questions? Okay, let's stop here. So I'm going to repeat my question at the beginning of this class is, so if you are graduating senior, and so you are going to graduate in May, and please send me an email and let me know. So I will arrange your final exam earlier. That's for graduating senior. Okay, if you don't have any question, let's end the meeting, and I will meet you on Wednesday. Okay, don't forget to type your name in the chat box for your attendance.